Hi friends, welcome to Tneb Gate is Education. So before going to start this question, okay, நான் தமிழ்லவே போயிடுறேன். என்னோட சப்ஸ்கிரைபர்ஸ்க்காக, என்னோட வீடியோஸ் பார்க்குறவங்களுக்காக ஒரு விஷயம் சொல்ல விரும்புகிறேன். பாருங்கள் ஃப்ரெண்ட்ஸ், இங்கே இப்போ இருக்கிற சிச்சுவேஷனில் ஸ்டூடெண்ட்ஸ் வந்து காம்படிட்டிவ் எக்ஸாம் ப்ரிப்பேர் ஆகிற ஸ்டூடெண்ட்ஸ் வந்து 3 விதமாக இருப்பாங்க. 3 கேட்டகரி. ஃபஸ்ட்டு கேட்டகரிக்காரங்க என்ன பண்ணுவாங்க? ஃபஸ்ட்டு கேட்டகரி ஸ்டூடெண்ட்ஸ் எக்ஸாம் எப்போ வேணாலும் வரட்டும், அவங்க படிச்சுட்டே இருப்பாங்க. ஸோ ரிவிஷன் பண்ணிட்டே இருப்பாங்க. ஸோ படிச்சுட்டு இருப்பாங்க, ரிவிஷன் பண்ணிட்டே இருப்பாங்க, டெஸ்ட் சீரீஸ் ப்ராக்டிஸ் பண்ணுவாங்க. ஓகேவா? ஸோ அவங்க வந்து எக்ஸாம் வர்றது, எக்ஸாம் எப்போ இருக்கும், இந்த மாதிரி நியூசன்ஸ் எல்லாம் அவங்க மைண்டில் வச்சுக்க மாட்டாங்க. டிஆர்பி இல்லையா டிஎன்இபி இருக்குது, டிஎன்இபி இல்லையா பின்னாடி என்எல்சி இருக்குது, என்எல்சி இல்லையா பின்னாடி ஐஏஎஸ் எக்ஸாம் இருக்குது, இல்லையா கேட் எக்ஸாம் இருக்குது, பின்னாடி ஏதோ ஒன்று இருக்குது. ஓகேவா? அவங்க அந்த பிளான் வச்சு போயிட்டே இருப்பாங்க. ஓகேவா? ஸோ படித்தது எப்போ வீணாகாது. ஓகேவா? ஸோ ஏதோ ஒரு எக்ஸாமில் ஏதோ ஒரு முன்னாடி வந்துடுவாங்க. விடாமுயற்சி வெற்றிக்கு வழி. விடாமுயற்சி வெற்றிக்கு வழி. அது அந்த ஃபஸ்ட் கேட்டகரி ஸ்டூடெண்ட்ஸ். அவங்க வந்து எக்ஸாம் இந்த நேரத்தில் இருக்கும், இந்த கொரோனா வைரஸ்னால எக்ஸாம் தள்ளி போகும், எக்ஸாம் கேன்சல் ஆகும், இதெல்லாம் யோசிக்க மாட்டாங்க. நடந்தால் நம்ம எக்ஸாம் பின்னாடி ஒரு எக்ஸாம் இருக்கும், அது பின்னாடியில் கேட் இருக்குது, போயிட்டே இருப்பாங்க. செகண்ட் கேட்டகரி வந்து அது எந்த ஸ்டூடெண்ட், அது எந்த மாதிரி ஸ்டூடெண்ட்ஸ்னால் அவங்களுக்கு சப்ஜெக்ட் நல்லா தெரியும், எல்லாம் படிச்சிருப்பாங்க. ஓகேவா? ஆனால் என்னென்னா எக்ஸாம் டைம் வரட்டும், எக்ஸாம் டேட் கொடுக்கட்டும், இல்லை எக்ஸாம் அப்போ இருக்கல வர்றப்போ பார்ப்போம், சின்னமாக படிப்போம், இந்த மாதிரி நெக்லிஜென்ஸ்னால அவங்க அப்படியே விட்டுட்டு போயிட்டே இருப்பாங்க. ஸோ விட்டுட்டு போகிறதுனால என்ன ஆகும்? எக்ஸாம் டேட் சப்போஸ் இப்போ அவங்க விட்டுட்டு போயிட்டே இருப்பாங்கன்னு நினச்சிக்கங்களேன். ஸோ எக்ஸாம் டேட் திடீர்னு வந்து ஆகஸ்ட் 31 இல்லை செப்டம்பர் 1 இல்லை செப்டம்பர் 10 ஒரு மாதம் முன்னாடி அறிவிச்சிட்டா அவங்க அப்போ வந்து என்ன ஆகுன்னு தெரியுமா? சடனாக ஒரு பர்டன் வரும். நம்ம இப்போ நிறைய ரிவிஷன் பண்ணணுமே, நிறைய படிக்கணுமே, ரிவிஷன் பண்ணணுமே, சில மறந்து போயிட்டோமே. ஓகேவா? ஸோ நம்ம எலக்ட்ரிக்கல் சப்ஜெக்டெல்லாம் வேஸ்ட் சிலபஸ், படிச்சுட்டா இருக்கணும், ரிவிஷன் பண்ணிட்டா இருக்கணும், அப்போ தான் ஞாபகம் இருக்கும். மோர் ப்ராக்டிஸ். ஓகேவா? ஸோ செகண்ட் கேட்டகரி ஸ்டூடெண்ட்ஸ்க்கு எல்லாம் தெரியும். ஆனால் என்ன பண்ணுவாங்க? டியூ டு நெக்லிஜென்ஸ்னால, ஓகேவா, 85 மேலே எடுக்க வேண்டிய மார்க்கை அவங்க என்ன அந்த நெக்லிஜென்ஸ்னால 60-70 வந்துடும். அவங்க எப்போ ஃபீல் ஆகும் தெரியுமா? எக்ஸாம் முடிஞ்சு ரிசல்ட் எல்லாம் வந்ததுக்கப்புறம் அப்படியே 15 மார்க்கில் வேலை போயிடுச்சு, நம்ம அன்றைக்கி படிக்காமல் விட்டுட்டோமே அந்த கொரோனானால. அவங்க அப்போ அடுத்த மாதம் அடுத்த வருஷம் சொல்கிறேன், ஒருத்தன் டிசம்பரில் சொல்கிறேன், அதெல்லாம் கேட்காம படிச்சிருக்கலாமே அப்போ தோணும். அது என்னமோ நான் என்ன சொல்கிறேன், இப்போ படிங்க, பின்னாடி எத்தனை எக்ஸாம் இருக்குது. ஒருவேளை இன்ட்ரெஸ்ட் வரலையா, ஏதோ ஒரு ஐஏஎஸ் ப்ரீவியஸ் கொஷின்ஸோ இல்லை ஏதோ ஒரு யூடியூப் சேனலில் போய் நீங்களே ஒரு கொஷின் சால்வ் பண்ணி பாருங்களேன். அப்போது உங்களுக்கு பயம் வரும். சால்வ் பண்ணாமல் இடத்துல உங்களுக்கு பயம் வரும், அப்போ படிப்பீங்க. ஓகேவா? ஸோ என்னோடய நண்பர்கள் வந்து டிஆர்பி பாலிடெக்னிக் லெக்சர் எக்ஸாமில் டாப்பில் வரணும், டிஎன்இபியில் டாப்பில் வரணும் அது நினச்சி தான் நான் சொல்கிறேன். இங்கே கேட்டகரி 3 ஸ்டூடெண்ட்ஸ் இருக்காங்க, அதெல்லாம் வந்து கண்டுக்க தேவையில்லை. அவங்க எல்லாம் வந்து சும்மா எக்ஸாம் ஹாலுக்கு வர்றது, எறும்பு விடுறது, இல்லை சும்மா 10 நிமிஷம் எக்ஸாம் போகிறது. ஸோ ஐ டோன்ட் பாதர் அபவுட் தட். ஸோ கேட்டகரி 1 ஸ்டூடெண்ட்ஸ் பார்த்து நான் பாதர். கேட்டகரி 2 ஸ்டூடெண்ட்ஸ் இப்போ வந்து கொரோனா வைரஸ்னால இதெல்லாம் யோசிக்காது. ஒருத்தன் சொல்லுவான் அவனுக்கு வேலை இல்லை, புரிஞ்சதா? வேலை இல்லாதவன் நிறைய சொல்லுவான். நம்ம பாட்டுக்கு நம்ம வேலை செஞ்சுட்டு போயிட்டே இருக்கணும். அவன் சொல்கிறான்ல, இவங்க சொல்கிறாங்களே, அவன் வந்து நம்ம சோறுக்கு போட மாட்டான், இவன் வந்து நம்ம சோறு போட மாட்டான். நம்ம கஷ்டப்பட்டால் தான் நமக்கு சோறு கிடைக்கும், நம்ம கஷ்டப்பட்டால் தான் நமக்கு வேலை கிடைக்கும். ஓகேவா? ஸோ படித்தா ஒரு எக்ஸாம் போச்சா, டிஆர்பி போச்சா, டிஎன்இபி இருக்குது, டிஎன்இபி போச்சா, என்எல்சி இருக்குது, என்எல்சி போச்சா, பின்னாடி என்னென்னமோ எக்ஸாம் வருது. எக்ஸாம் வராமல் ஒன்றும் இருக்காது. ஸோ லீவ் தீஸ் ஆர் unnecessary திங்ஸ். ஓகேவா? ஸோ ப்ரிப்பேர் பண்ணுங்கள், அதுதான் நான் சொல்ல விரும்புகிறேன். ஸோ யாரையாச்சும் ஹட் பண்ணுன்னா ஐ எம் வெரி சாரி. ஓகே, ஸோ லெட் ஸ்டார்ட் தி கொஸ்டின். ஸோ கொஸ்டின் என்ன கொடுத்துருக்காங்கன்னா, ஐடென்டிக்கல் சிங்க்ரனஸ் மிஷின் ஏ அண்ட் பி, ரெண்டு சிங்க்ரனஸ் மிஷின் கொடுத்துருக்காங்க, ரன்னிங் எட் தி சேம் ஸ்பீட். ஓகேவா? த்ரூ இண்டக்டர். ஸோ மிஷின் ஏ வந்து ஆக்டிவ் பவர் ரியாக்டிவ் பவர் சப்ளை பண்ணணும், இந்த கண்டிஷன் கொடுத்துருக்காங்க. ரைட். ஸோ உங்களுக்கு ஒன்று தெரியும். என்ன தெரியும்? சப்போஸ் இஃப் current leaves from positive terminal, it delivers. If current enters the positive terminals, it absorbs. Suppose if current is delivered from machine A, the current is going like this. Current இப்படி போகுது. So current. So machine A ல இருந்து current leave ஆகுது. machine B குள்ள current enter ஆகுது. machine B குள்ள current enter ஆகுது. if at all. Okay. So machine A ல இருந்து current leave ஆகுது. machine B குள்ள enter ஆகுது. machine A ல இருந்து current leave ஆகுதுன்னா it deliver. machine B குள்ள enter ஆகுதுன்னா it absorbs. Okay. So நம்ம மிஷின்ல பார்த்தீங்கன்னா which alternator delivers active power? Motor absorb, induction motor and synchronous motor absorbs real power. Right. Suppose if current is coming from machine B, okay, then machine B acts as a, then machine B delivers, it delivers reactive power, it absorbs, so it delivers active power, machine A absorbs active power. Okay, so current எங்கே இருந்து லீவ் ஆகுது பாருங்க. Okay, so machine A will supply active power, means current is coming from this, so it acts as a alternator, it delivers active power. Okay, it delivers active power. So alternator delta வந்து positive, உங்களுக்கு தெரிஞ்சதுதான். motorல delta வந்து negative. So machine A will supply active power when delta is positive. I can neglect these two options. So A and B. So இப்போ VA greater than VB யா, VA less than VB யா, இது நமக்கு தெரியும். ஸோ உங்களுக்கு என்ன தெரியும்? Q equal to V by XS E cos delta minus V. ஸோ நீங்கள் பார்த்தீங்கன்னா Q is positive. ஸோ நீங்கள் பார்த்தீங்கன்னா Q வந்து பாசிட்டிவ் ஆனால் டெலிவர் ஆகும், Q வந்து நெகட்டிவ் ஆனால் அப்சர்வ் பண்ணும். ஓகேவா? ஸோ இங்கே Q வந்து டெலிவர் பண்ணும், that is Q is positive. Q is positive means E greater than V, that is over excitation. That implies VA greater than VB. So VA greater than VB, over excitation தான் Q positive ஆகும், it delivers reactive power. Suppose Q is negative, that is it absorbs. நீங்கள் பார்த்தீங்கன்னா alternator it acts, machine A should be acts as a, உங்களுக்கு கொஸ்டின் பார்த்தீங்கன்னா this machine A acts as an alternator and it has to absorb reactive power. It has to absorb reactive power means Q is negative. So Q is negative means it should be VA less than VB. If it is under excitation, Q is negative. So இங்க பார்த்தீங்கன்னா reactive power deliver சொல்லிருக்காங்க. So machine A should be deliver reactive power and deliver active power. So deliver reactive power means VA excitation is greater than VB. So VA greater than VB. So answer is B. Okay, let's see the next question. An alternator on open circuit generates 360 volts at 60 Hz when the field current is 3.6 amperes. Neglecting saturation, the open circuit EMF when the frequency is 40 Hz and the field current is 2.4 amperes. அவன் என்ன கேட்டிருக்கான்? ஃபீல்டு கரண்ட் 3.6 ஆம்பியர் இருக்கிறப்ப 60 ஹெர்ட்ஜ் கிட்ட இஎம்எஃப் வந்து 360 வோல்ட் இருக்கிறப்ப 40 ஹெர்ட்ஜ் இருக்கிறப்ப ஃபீல்டு கரண்ட் 2.4 இருக்கிறப்ப ஓப்பன் சர்க்யூட் வோல்டேஜ் எவ்வளோ கேட்டிருக்காங்க. ஸோ உங்களுக்கு என்ன தெரியும், இஎம்எஃப் ஈக்குவேஷன் ஈக்குவல் டு இஎம்எஃப் ஈக்குவேஷன் பார்த்தீங்கன்னா 4.44 F5 N1 pitch factor into distribution factor. இது எனக்கு தெரிஞ்சது. ஓகேவா? ஸோ திஸ் இஸ் an EMF equation. ஸோ EMF தெரியும். ஓகேவா? ஸோ EMF இருக்கு, ஃப்ரீக்வன்சி இருக்கு. ஸோ ஃபீல்டு கரண்ட் 3.6 ஆம்பியர்ஸ் கொடுத்துருக்காங்க. ஸோ இங்கே ஃபீல்டு கரண்ட்டே இல்லையே. ஸோ ஃபீல்டு கரண்ட் இஸ் டைரக்ட்லி ப்ரொபோர்ஷனல் டு தி ஃப்ளக்ஸ். ஸோ இன்டைரக்ட்லி இட் இஸ் given as flux. So E1 by E2 F1 by F2 into phi1 by phi2. That implies E1 by E2 F1 by F2 IF1 by IF2. So இப்போ சப்ஸ்டிட்யூட் பண்ணுங்க. E1 எவ்வளோ? E1 வந்து 360, E2 கண்டுபிடிக்கணும். ஃப்ரீக்வன்சி 60 கொடுத்துருக்காங்க ஃபஸ்ட்டுது, அதுக்கப்புறம் 40 கொடுத்துருக்காங்க, அதுக்கப்புறம் 3.6 ஆம்பியர் கொடுத்துருக்காங்க, அதுக்கப்புறம் பார்த்தீங்கன்னா 2.4. ஸோ கேல்குலேட் பண்ணி ஆன்சர் என்னன்னு சொல்லுங்கள், E2 எவ்வளோன்னு சொல்லுங்கள். ஓகேவா? லெட்ஸ் சி நெக்ஸ்ட் கொஸ்டின். ஸோ நெக்ஸ்ட் கொஸ்டின் பார்த்தீங்கன்னா, இன் 3-phase 4-pole 50 Hz serial pole synchronous machine, how many times the reluctance seen by the armature MMF changes in 1 second? So question நல்லா பாருங்க. 3-phase 4-pole 50 Hz salient pole mission. ஸோ நீங்கள் பாருங்கள், இது salient pole mission. ஸோ எனக்கு ஹேண்ட் ரைட்டிங் நல்லா இருக்காது. ஸோ ஓகே ரைட், பரவாயில்ல, நல்லா தான் வந்திருக்கு. இது salient pole mission. Right. So it is salient pole synchronous mission, 3-phase. How many times reluctance seen by the armature MMF? Reluctance seen by the, இங்க பாருங்க, reluctance seen by the armature MMF. So flux equal to MMF by reluctance. That means reluctance seen by the armature. So indirectly the reluctance, flux always உங்களுக்கு என்ன தெரியும், flux always flows through the minimum reluctance path. Flux always flows through minimum reluctance path. Okay, so reluctance determine indirectly the flux. So reluctance ஜாஸ்தியா இருந்தா flux கம்மியா இருக்கும், flux reluctance கம்மியாக இருந்தால் ஃப்ளக்ஸ் ஜாஸ்தியாக இருக்கும். ஃப்ளக்ஸ் ஆல்வேஸ் ஃப்ளோஸ் டு தி மினிமம் ரிலக்டன்ஸ் பாத். ஓகேவா? ஸோ ரிலக்டன்ஸ் சீன் பை த ஆர்மேச்சர். ஸோ இது வந்து நீங்கள் உங்களுக்கு மிஷின்ஸில் தெரியும், ஆர்மேச்சர் இஸ் ஆன் தி ஸ்டேட்டார், வைண்டிங்ஸ் ரோட்டார், ஃபீல்டு வைண்டிங்ஸ் ஆன் தி ரோட்டார். ஸோ ஃபீல்டு ஆன் தி ரோட்டார். அது என்ன சொன்னால் ரிலக்டன்ஸ் சீன் பை தி ஆர்மேச்சர் MMF. ஸோ நீங்கள் பார்த்தீங்கன்னா சிங்க்ரனஸ் மிஷின் வந்து சிங்க்ரனஸ் ஸ்பீடில் ரொட்டேட் ஆகும், கான்ஸ்டன்ட் ஸ்பீட். இது நார்த் போல் அண்ட் சவுத் போல், இது வந்து சிங்க்ரனஸ் ஸ்பீடில் ரொட்டேட் ஆகுது. ஸோ இந்த சிங்க்ரனஸ் ஸ்பீடில் ரொட்டேட் ஆனதுக்கப்புறம் ஓகேவா, ஸோ வைண்டிங் கான்ஸ்டண்ட்டாக இருக்குது, ஃப்ளக்ஸ் வேரி ஆகுது, ரிலேட்டிவ் ஸ்பீடு இருக்குது, இங்கே இஎம்எஃப் இன்டியூஸ் ஆகுது. ஸோ க்ளோஸாக இந்த வைண்டிங்ஸ் ஆர்மேச்சர் வைண்டிங் க்ளோஸ் ஆகுதுனால உங்களுக்கு கரண்ட் வருது. ஸோ கரண்ட்னால ஆர்மேச்சர் MMF வருது. ஸோ இங்கே பார்த்தீங்கன்னா இதில் ஒரு நார்த் போல், இது சவுத் போல். ஸோ இது எவ்வளோ, இது எப்படி ரொட்டேட் ஆகுது, இது ரொட்டேட்டிங் மேக்னெட் ரொட்டேட்ஸ் அட் சிங்க்ரனஸ் ஸ்பீட். ஸோ இது எவ்வளோ ஸ்பீடில் ரொட்டேட் ஆகுது, இது எவ்வளோ ரொட்டேட். ஸோ நீங்கள் பார்த்தீங்கன்னா ஆர்மேச்சர் MMF இஸ் ஸ்டேஷனரி வித் ரெஸ்பெக்ட் டு தி ரோட்டார். ஆர்மேச்சர் MMF நீங்கள் பார்த்தீங்கன்னா ஆர்மேச்சர் MMF இஸ் ஸ்டேஷனரி வித் ரெஸ்பெக்ட் டு தி ரோட்டார். உங்களுக்கு ரிலேட்டிவ் ஆர்மேச்சர் MMF ஃபீல்டு MMF ரிலேட்டிவ் ஸ்பீடு வந்து 0 ஆனால் தான் உங்களுக்கு சிங்க்ரனஸ் ஸ்பீடில் ரொட்டேட் ஆகும். கரெக்டாக இல்லையா? அதே வந்து நீங்கள் பார்த்தீங்கன்னா ரிலேட்டிவ் ஸ்பீட் பிட்வீன் தி armature mmf and field mmf in induction machine is a not equal to 0, whereas in synchronous machine it is a 0. It is a 0. So question paranga, how many times the reluctance seen by the armature? So armature, how many times the reluctance seen by the armature mmf changes in 1 second? அட கடவுளே, ரிலக்டன்ஸ்னா ஃப்ளக்ஸ். ஓகேவா, நீங்கள் ஆர்மேச்சர் எம்எம்எஃப் நீங்கள் எத்தனை தடவை ரொட்டேட் பண்ணாலும், நீங்கள் ரோட்டார் எத்தனை தடவை ரொட்டேட் பண்ணாலும், இந்த ஆர்மேச்சர் எம்எம்எஃப் வித் ரெஸ்பெக்ட் டு ரோட்டார் இஸ் ஆல்வேஸ் ஸ்டேஷ்னரி. புரிஞ்சிச்சா? ஸோ ஆர்மேச்சர் எம்எம்எஃப் ஸ்டேஷ்னரியாக இருக்குன்னா ரிலக்டன்ஸ் ஸ்டேஷ்னரியாக இருக்கும். ரிலக்டன்ஸ் வந்து ஃப்ளக்ஸை டிட்டர்மின் பண்ணுது. ஓகேவா? ஸோ ஆர்மேச்சர் ஃப்ளக்ஸ் வந்து இஸ் ஸ்டேஷ்னரி வித் ரெஸ்பெக்ட் டு தி ரோட்டார் ஃப்ளக்ஸ். தென் ஓன்லி உங்களுக்கு ஒன்று தெரியும் ஆல்ரெடி பேசிக்ஸில் பாருங்கள், த ஆர்மேச்சர் ஃப்ளக்ஸ் அண்ட் ஃபீல்ட் ஃப்ளக்ஸ் மஸ்ட் பி தேர் அண்ட் ரிலேட்டிவ் ஸ்பீட் மஸ்ட் பி 0 ஃபார் தி டார்க் ப்ரொடக்ஷன். Relative speed must be 0 for the torque production. That means with rendu vandu constant, rendu vandu, so armature mmf is related, armature mmf is stationary with respect to the is stationary. அது வந்து ரெண்டு ஒரே இது வந்து சிங்க்ரனஸ் ஸ்பீடில் போனால் இங்கே பாருங்கள், இது சிங்க்ரனஸ் ஸ்பீடில் போனால் இவன் சிங்க்ரனஸ் ஸ்பீட். ஸோ நானும் சிங்க்ரனஸ் ஸ்பீடில் போகிறேன், என் ஃப்ரெண்டு சிங்க்ரனஸ் ஸ்பீடில் போகிறான். ஒரே ஸ்பீடில் போகிற ரெண்டு பேர் எப்படி தெரியும்? ஒரே மாதிரி இருக்கும். ஸோ ரெண்டு பேரும் ஒரே பொசிஷனில், ஸோ ஸ்டேஷ்னரியாக இருக்கிற மாதிரி தெரியும். ஓகேவா? ஸோ reluctance seen by the armature mmf changes in 1 second is 0. ஸோ கொஸ்டினில் ஒன்றுமே இல்லை, அங்கே ரிலக்டன்ஸ் கொடுத்துருக்காங்க ஃப்ளக்ஸ் பதிலாக. ஓகேவா? ஸோ ரிலக்டன்ஸ் சீன் பை த ஆர்மேச்சர் எம்எம்எஃப் மீன்ஸ் இன்டெரக்ட்லி த ஃப்ளக்ஸ் சீன் பை த ஆர்மேச்சர் எம்எம்எஃப். ஃப்ளக்ஸ் சீன் பை த ஆர்மேச்சர் எம்எம்எஃப் வித் ரெஸ்பெக்ட் டு அதாவது சேஞ்சஸ் இன் 1 second. How many times changes means with respect to rotor, how many times it changes? With respect to rotor it changes, it nothing changes. It nothing changes. Okay, right. So these are the இன்னொரு கொஸ்டின்ஸ், இன்னும் ரொம்ப நல்ல கொஸ்டின்ஸ் அடுத்த வீடியோவில் பார்ப்போம். ஸோ பிடிச்சிருந்தா ஷேர் பண்ணுங்கள், சப்ஸ்கிரைப் பண்ணுங்கள். தேங்க்யூ. Hi friends, welcome to KMED Gates Education. Let's see the question from network theory. In the circuit shown in the figure, it is known that variable current source absorbs power the direction of the eye in such a way that it receives maximum power. The amount of power absorbed by it is. So you can carefully observe the question. What he asked is the amount of the power absorbed by it is. So here the question variable current source is this. The amount of the power absorbed by it is what, such that it receives the direction of the current I such that it receives maximum power. Okay, so it receives maximum power. He find the amount of the power absorbed, and also you note that here in the question it is given absorbed. Okay, we know that very well. Suppose if I have a independent voltage source, if current leaves from the positive terminal, it delivers power. If current enters the positive terminal, this voltage source absorbs the power. Similarly, if I have a current source here, if I place positive negative here, the current is coming out from positive terminal, it delivers power. If I place negative positive here, the current entering the positive terminal or leaving the negative terminal. So current enters the positive terminal, so it absorbs power. So current entering the positive terminal absorbs the power, current leaving the terminal it delivers power. Okay, so you can see here, if I place under arrow negative sign and I place under without arrow plus sign, it absorbs power. So from this you can see here, this will be the plus and this will be the minus. Let this node voltage is VA and this node voltage is VB. Okay, so finally he asked that power absorbed by this element. Power absorbed formula is power equal to V into I. We know that here voltage across that element is VAB into I. This is power absorbed. okay, and VAB equal to VA minus VB into I. So if I found VA minus VB into I, then I get the power absorbed, but he given that the direction of the I is such that it receives maximum power. So here in the question, the direction of I is such that it receives maximum power. Let see here what is the here the voltage 24 volts. What is the here voltage 24 volts. What is here voltage 24 volts. So what is the voltage here 0 volts. What is the voltage here 0 volts. What is the voltage here 0 volts. So what is the current flowing through this. What is the current flowing through this. What is the current flowing through this branch. What is the current flowing through this branch, and what is the current flowing through this branch. You can see here what is the current flowing through is 24 minus VA by 3. What is the current flowing through this branch. VA minus 0 by 6. What is the current flowing through this. 24 minus VB by 4. What is the current flowing through this. VB by 4. Okay, VB minus 0 by 4. You apply KCL at A and KCL at node B. Apply KCL at node A and node B. So you can see here 24 minus VA by 3 is entering and current source is leaving, and VA by 6 is leaving. Okay, so 8 minus VA by 3 equal to I plus VA by 6. So VA by 6 plus VA by 3 equal to 8 minus I. So 3 VA, 2 VA, VA plus 2 VA, 3 VA by 6. 3 VA by 6 is VA by 2 equal to 8 minus I. So VA equal to 16 minus 2I. So I found VA. Similarly, find VB. Find VB. If I find VB, you can see here 24 minus VB by 4 is entering, current is also entering, VB by 4 is leaving. So I want VB 4 6 plus I VB by 4 plus VB by 4, that equal to VB by 2, that equal to 6 plus I. So VB equal to 12 plus 2I. 12 plus 2I. Okay, so this is equation 1 and this is equation 2. So VA minus VB, what is VA minus VB? 16 minus 2I minus 12 minus 2I. So this is 4 minus 4I. So this is V, total voltage V. Okay, so V equal to VA minus VB, V equal to 4 minus 4I. You can see here power equal to V into I. So 4 minus 4I into I. So 4I minus 4I square. But here in question he given that it receives maximum power. The direction of the I is such that it receives maximum power. So the given power is the function of the I. So I can write this as dP by, for receive maximum power, dP by di equal to 0. So if I make differentiable 4 minus 8I equal to 0, so 4 equal to 8I, I equal to half. So this is the optimum value for receiving maximum power. So what is the value of the I? You can get the question also. What is the value of the I such that it receives maximum power? I equal to half. So now what is the power? Power equal to V into I. So I know I. What is the voltage here? Voltage equal to 4 minus 4I. What is the optimum value of I? 1 by 2. So 4 minus 4 into half, that equal to 4 minus 2, 2. Okay, so voltage is 2, current is half, that equal to 1 watt. Power is 1 watt. Okay, so power absorbed is 1 watt. Let's see the next question. So let's see the next question here. Two networks is shown, and between two networks you have a resistance and independent current source. The value of the I in the figure. He asked the value of the I. Suppose if I have I have a 3 volts here, and I have, let's say, 2 ohms here. Let I have here of 2 volts. So what is the current flowing here? 3 minus 2 by 2 is how much? 1 ampere. How much current is flowing through the circuit? 1 ampere. So whatever the current flowing through this, it will come here, it will come here, it will goes like this. Okay, so current entering from one network to the one network. So if you consider this is if you consider this as one network, 3 voltage source, and if I consider this is one network, so whatever the current entering here and the current leaving here, so whatever the 1 ampere is going from here node A to node B, and the same current will comes from this network. So whatever the current flowing from this network to network, the same current leaving from this network to the network. Similarly here, later whatever the current, let's see here, what is the current flowing here? He asked that. Okay, so what is the current flowing through this 120 ohms? You have 100 volts, so I equal to V by R. So 100 by 20, 5 amperes. So what is the current flowing here? 5 amperes, like this. This is 5 amperes. This is 5 amperes. So current through the passive elements always from positive to negative. Current through the passive elements is always from positive to negative. Okay, so you can observe here 5 amperes is coming this node, and here 4 amperes is coming. Okay, so you can see here I is coming. So to this node, to this circuit, suppose if I take this as a two single elements, that is total 9 currents. So if I bunch this, total 9 currents is flowing. If I 9 current is flowing, means in this 9 currents should be leave. Same circuit 1 to, if circuit 1 to circuit 2, total of 9 current is entering into this, and 9 amperes is entering, means 9 amperes is leaving. But the direction of the current should be in 9 amperes in this direction, but the direction of the current is given in this direction. It should be of minus 9 amperes. But you can also apply KCL simply. KCL. You can see here, this is, you take this network simply one node. So the here current entering is I, here current entering is 5 amperes, 100 by 25 amperes, here current entering is 4 amperes. So I plus 5 plus 4, current leaving is 0. So I don't know current leaving, no current is leaving from that node. So only all current are entering, no current is leaving. Okay, so current leaving is 0, only currents are entering, no current is leaving. So I equal to minus 9 amperes. Okay, so let's see the next question. It is from control systems. The unit step response of a unity feedback system with open loop transfer function, it is given. The value of the K. He asked the value of the K, and the response is given. One should you carefully observe that it in the question it is G of S, H of S is given, but he is telling that the unit step response of a unity feedback system. Okay, so that is H of S is 1. So G of S, h of s is k by s plus 1 whole square into s plus 2. Okay, so let's go for method 1. Method 1. He said that unit step response of a unity feedback system with open loop transfer function is given. So what is a closed loop transfer function? What is a closed loop transfer function? C of s by r of s, or y of s by x of s, g of s by 1 plus g of s, because it is a unity feedback system. For the confusion only, he is given in the question g of s, h of s. It is a g of s only. Okay, so or if you place, so he is given open loop transfer function, we have to place h of s equal to 1. Okay, so indirectly he is given g of s only. Okay, so g of s is k by s plus 1 whole square into s plus 2 by 1 plus k by s plus 1 whole square into s plus 2, that equal to k by s plus 1 whole square into s plus 2 plus k plus k. This is closed loop transfer function C of s or by r of s, but he is given unit step response. This is unit step response. So C of s, r of s is 1 by s, r of s is 1 by s. So C of s is k by s into s plus 1 whole square into s plus 2 plus k plus k. So you can see here from this figure, what is the final value? Final value is 0.8. What is the final value? Final value is 0.8 or steady state value. What is this? Steady state value is 0.8. Steady state value is 0.8. Okay, so limit final value, that is limit t tends to infinity, c of t, that equal to limit s tends to 0, s into c of s equal to 0.8. So if I place here, if I substitute there, limit s tends to 0, s k by s into s plus 2 into s plus 1 whole square plus k equal to 0.8, ss cancel. So k by 2 plus k equal to 0.8. I replace s equal to 0, s equal to 0. So 0.8. So k equal to 0.8 into 2 plus 0.8 into k. So 1.6 plus 0.8 k, that equal to 1.2. So 0.2 k equal to 1.6, 1 minus 0.8 into k, so k equal to 8. So this is one method. So this is one method. So we know that what is steady state error. So first of all, what is this? What is the type of the system? This is a type 0 system. This is a type 0 system. So for type 0 system, if you have a unit input, unit step input, for type 0 system, you have unit step input. What is steady state error? Steady state error equal to a by 1 plus kp. So a equal to 1 here. He does not given the magnitude of the unit step function. That let's take a equal to 1. Okay, so kp equal to positional error constant, limit s tends to 0, g of s. Okay, so here what we do here is, sir, steady state error is limit s tends to 0, s into r of s by 1 plus g of s. So how can I solve from this? But we know that error is nothing but a deviation of output from input, deviation of output from input. This letter, this is an input and this is output. So error is deviation of the output from input. What is steady state error? So steady state error equal to limit t tends to infinity, r of t minus c of t. So for type 0 system, what is the steady state error? 1 by 1 plus kp. 1 by 1 plus kp. So what is r of t? R of t is a input, c of t is a output. As t tends to infinity, what is the input? So the given input is unit step function. As t tends to infinity, what is the input? 1. What is the input? 1. As t tends to infinity, what is the output here? What is the output here? As t tends to infinity, you see here, as t tends to infinity, what is output here? Final value. T tends to infinity means final value, that equal to 0.8. That equal to 0.8. So 1 minus 0.8, 1 by 1 plus kp. So limit s tends to 0. G of s. What is the g of s given? G of s is given k by s plus 1 whole square into s plus 2. So k by s plus 1 whole square into s plus 2. So let replace s by 0. So I am replacing 0, I am replacing 0. So what I get here? 1 minus 8 is 0.2. 1 by 1 plus k. 1 into 2, 2. Right? So 1 plus s plus 1 into 2, right? Okay, so 1 plus k by 2, you see here, 1 plus k by 2 equal to 1 by 0.2, how much? 5. 1 by 0.2, how much? 1 plus s plus 2, right? Sorry, okay, 1 plus k by 2, right. 1 minus 0.8 is 0.2, so 5. So k by 2 is 4. 5 minus 1 is 4. K is 8. K is 8. Okay, so I did not any do mistake. So k by 1 plus k by 2 equal to 5, k by 2 equal to 4, k equal to 8. So you get the answer, k equal to 8. So here error is nothing but deviation of the output from input. Steady state error equal to limit t tends to infinity, r of t minus c of t. As t tends to infinity, what is input? Given input is unit step input. Unit step input is, it is a 1. Okay, so it is a 1. And c of t output, what is as t tends to infinity, final value is 0.8. So if you substitute this, you get the answer. This is the method 2 approach. Okay, so whatever the method is easy for you, you can follow that. Okay, thank you. Hi friends, welcome to K-Made Gate's Education. Let's see the question from transformer. Here two transformers are connected in cascade. He asked the question, find the magnitude of the current I2. Find the magnitude of the current I2 and find the magnitude of the current I3 and find the magnitude of the impedance seen by the voltage source from V1. So this is the question given. So you can see here, first I consider this transformer. I consider this transformer. We know that transformation ratio V2 by V1 equal to N2 by N1 equal to I1 by I2 equal to K. This is the transformation ratio. Here you can see I know supply voltage 400 volts. I don't know about V3 and V2. Okay, so if at all I know load impedance 40 ohms, I did not know current. Here V3 is unknown value and I3 is unknown value. So if I know one known value from this, then I can find this value. So I cannot go from this side. I can go from this side because I know supply voltage is 100 volts. I can find easily V2. So apply transformation ratio V2 by V1 equal to N2 by N1. So V2 equal to, what is N2? 2 by 1 into 400, that equal to 800 volts. So V2 is 800 volts. So whatever the voltage in secondary terminal of the first transformer is applied to the primary terminal of the second transformer. So this is 800 volts and this is 800 volts. Because we are considering only ideal transformer, here no resistance is given, so it is an ideal transformer. So apply again transformation ratio. So V3 by V2, that equal to V3 by V2 equal to 4 by 1 by 4. V3 by V2, secondary side by primary side equal to secondary turns by primary turns. Okay, so V3 equal to 1 by 4 into how much is V2? V2 is calculated 800, that equal to 200 volts. So V3 is 200 volts. So V2 is 800 volts. V3 is 200 volts. Okay. Now I want to find I3. First he asked me find the magnitude of the current I3. So if I know V3, I can find I3. So I3 equal to V3 by R3. So V3 is 200. 200 by 40, 5 amperes. So it is a 5 amperes. So I know 5 amperes here. I know turns ratio. I can find easily I2. So I3 by I2 equal to transformation ratio 4 by 1. So I3 I know, I2 equal to 5 into 1 by 4. So this is 5 by 4 amperes. I2 is 5 by 4 ampere. So if at all he asked I1 also, if he asked I1 also, how can I do? Same, apply transformation ratio. I2 by I1 equal to 1 by 2. So I1 equal to, what is I2 here? 5 by 4. 5 by 4 I1. Okay. So into 2. That equal to 5 by 2. I2 is how much? I1 it goes here. I2 is 5 by 4. 2 will be multiplied. 2 2s for 5 by 2. That is 2.5 amperes. 2.5 amperes. So what he asked, the magnitude of the impedance seen by the source V1. So when I seen from the source V1, when I seen from this source V1, Z1 equal to Z equal to V1 by I1. I know V1 400. What is I1? I1 is 2.5. So what is 400 by 2.5? 400 divided by 2.5 equal to 160 volts. How much? It is 160 ohms. 160 ohms. So impedance seen from this here is V1 by I1. V1 by I1. Or you can check from this also. How much I get? 160 ohms is get. How much I get? 160 ohm. I get the answer. So let's check in another way. Let's check in another way. So when I transfer from secondary to the primary, you see here, I am transferring this 40 ohms here to here divided by k square. Okay. When I transfer from secondary to primary, it is divided by k square divided by transformation whole square. When I transfer from here to here, it is primary to secondary, it is multiplied by k square. You know very well about that. So you can see here, when I transferring from secondary to primary, 40 by k square. So what is k? 40 by 1 by 4 whole square. 40 by 1 by 4 whole square. So 40 into 4 square. 40 into 4 square. So up to this, what is the equivalent impedance? 40 by k square, 40 into 4 square. So again I transfer from up to here, I have impedance 40 into 4 square. When I transfer from here to here, 40 by 4, 40 into 4 square by what is k square? K square is 2 square, 4. 2 square, 4. So 4 cancel, 4 into 4, 40, 160 ohms. So you can check here also, when I transfer from secondary to primary divided by k square. When I transfer from primary to secondary, it is multiplied by k square. Finally, you can get 160 ohms. So you can go and in the two methods. Okay. So it's simply Z equal to, whenever impedance seen from that source, Z equal to V by I. I know V1 and I1. So matter is over. So if at all, if you go in transformer analysis, that is divided by equivalent resistance method, so you can go that method also. Okay, let's see the next question. So let's see the next question here. The same transformer, cascaded 2 transformers, ideal transformer is given, and their rating and voltage ratings is given. What is the first question? What is the maximum value of the supply voltage that can be connected without overrating of transformer? That is the first question. So how much is the maximum voltage that I connect to the primary? Second question is, what is the maximum value of the supply current that can be done without overrating of the transformer? Okay. And the third question, what is the maximum value of the kVA without overrating of the machine? Okay. Fourth question is, suppose if I connect the whatever the maximum supply voltage I have calculated that I connected, under this condition, what should be the value of this load resistance R? This is the question. So let's see here. First of all, you see here, this is primary transformer, this is first transformer and secondary transformer. Okay, and first of all, let take what is the current here and what is the current here. Let's find that. So here 5000 by 100, so 50 ampere is the current flowing in secondary of the primary transformer, secondary of the second transformer, and primary is 5000 by 1000, 5000 by 1000. So you have 5 amperes here, 5 amperes here. So how much current here flowing here in the secondary of the first transformer? So 4.4 kVA divided by 1100, 4.4 kVA divided by 1100, 4 amperes. So here 4 amperes is going, 4 amperes is going. Similarly 4.4 kVA divided by 110, so here 40 amperes is going. So here 40 amperes is going. Okay, so you can see here the secondary of the primary the secondary of the first transformer and the primary of the transformer connected in cascade. So in this winding the current limit is 4 amperes only. In this winding the current limit is 5 amperes, but two are connected in series. So what is the limit in this? What is the maximum current that can flow in this winding? What is the maximum current that can flow in the secondary of the first transformer and the primary of the second transformer? So minimum of this current 4. So secondary winding has a 4 amperes current only. It can deliver 4 amperes current only, but it can accept 5 amperes, but both are connected in cascade, so it can able to take only 4 amperes current. It can able to take only 4 amperes current. Okay, so if 4 amperes current it is taken, what is the primary current? So what is the primary current? Apply transformation ratio I2 by I1 equal to N1 by N2. So I2 I know 4 amperes, I1 is I have to find, N1 is how much? 110. This is equal to 1100. So you can see here 11 tenths. So I1 equal to 40 amperes. So this supply current is 40 amperes that can take without overrating of the transformer. So it can take 40 amperes. It can take 40 amperes. Right. And again see here. Again you can see here. This primary of the second transformer has a supply voltage of 1000 volts. 1000 volts. It has a voltage of 1100 volts. It has a voltage. Secondary of the first transformer has a voltage of 1100 volts. So you can see here. These are, so this is the voltage and this is voltage between the secondary of the first transformer and the primary of the first transformer. There is no resistance. So whatever the voltage here, that will apply to the primary. So it can maximum, you can see here, this is 1100 and this is 1000 volts. So how much voltage you can apply? So here generate in the secondary side, it is generating 1100, but we can apply only 1000 voltage. So it can take only in secondary it requires only 1000 voltage. Okay, I am applying primary of the second transformer 1000 volts, but I don't require 1100 volts, so it can only require 1000 volts. It require only 1000 volts. So I know V2 is 1000 volts. Apply transformation ratio. If you apply transformation ratio, V2 by V1 equal to N2 by N1. So V2 is how much? 1000. So I want to find V1. So N2 how much? N2 is how much? 1100 by 110. So 110 tens. So this 10 this cancel. V1 equal to 100 volts. Okay, so V1 equal to 100 volts. So this is the maximum supply voltage that can we apply on the primary side of the transformer without overrating of any of the transformer. Next question he asks, that is, next question is, so what is the maximum supply voltage? Here 100 volts. So I know here 100 volts. You see here, I know this is 100 volts, and overrating, without overrating current is 100 amperes. So what is the maximum kVA? 100 into 40, that equal to 4 kVA. Is the maximum value of the kVA that can be transmitted to the load without overrating of the mission. Okay, so transformer. So suppose we have connected the maximum allowable supply voltage Vs. What is the maximum allowable supply voltage? Vs is 100 volts. Under this condition, what will be the minimum value of the load resistance? Okay, that can be connected without override. You can see here, if I connect 100 volts here, what is the current here? 40 amperes. My maximum supply voltage, I have maximum supply current of 40 amperes. So here I have a 4 amperes. The 5 amperes will not here taken. So here 4 amperes. So what is the current here? So what is the current here? If I have a 4 amperes, what is the current here? I2 by I1 equal to N1 by N2. So what is the current here? So I want to find current in that. So this is 4 amperes. So 1000 by 100. It will cancel. So I2 equal to 40 amperes. How much current it will flows in this load? 40 amperes will flow. You understand? So here 4 amperes will flow. I am applying transformation ratio to the secondary of the transformation to the second transformer, which is connected in cascade to the primary transformer. I will getting 40 amperes. What is V2 here? V2 is you apply here 1000 only. It requires only 1000 volts. So if it is 1000 volts, it only 100 volts only. So it is of 100 volts. If you apply, you get 100. For 1000 volts, I am applying correctly. For second transformer, I am applying 1000 volts only. So you get secondary automatically 100 volts. Okay, so 100 volts. So V2 is 100 volts. So V3 is 100 volts. So finally, load resistance equal to V by I. So 100 by 40. So 10 by 4. 428, 2.5. So what is the value of the load resistance that can be connected? 2.5 ohms. 2.5 ohms. Okay, so you have clear idea how to solve this problem. So let's see the next question here. This is simply given 3-phase transformer. Okay, so telling to 3-phase transformers, 3 windings on a single phase transformer. Okay, so it is not a 3-phase transformer, it is a 3 windings on a single phase transformer. Okay, it is not a 3-phase transformer, 3 windings on a single phase transformer. So he asked that, he given the turns ratio, and Z2 is given 5 ohm resistance, Z3 is given. He asked to find I2, find I3 and find I1, and also find the impedance seen by the voltage source. So let's see here. If you here given Z2 is given how much? This is a 5 ohms, and Z3 is given, this is of 6 ohms. I2 equal to V2 by Z2, so V2 by 5, and I3 equal to V3 by Z3. V3 equal to how much? I don't know, V3 by 6 ohm. Okay, and we know that MMF balance N1 I1 equal to N2 I2 plus N3 I3. So what is MMF balance here? Suppose if primary winding having N turns carrying a current I1 produces a flux phi1. Okay, so N1 I1 MMF produce a flux phi1. This flux linking with the secondary and tertiary winding produces a EMF E2 and E3, and this E2 E3 produces a current in this winding, and this winding flowing through the coil having a N2 and N3 turns. Okay, so this E3 produces I3 and this E2 produces I2 and produces a MMF N2 I2 and produces MF N3 I3 and produces a flux. MMF produces a flux. That flux opposes this main flux because of Lenz's law. So it produces a flux phi2 opposite to the phi1, and it produces a phi3 that opposite to the phi1. Okay, so applying Kirchhoff's flux law, or you can balance that. So phi1 equal to phi2 plus phi3, then only net resultant flux balanced. Okay, so similarly N1 I1 equal to N2 I2. We know that I1 equal to N2 I2 by N1, N3 I3 by N1. Okay, so N2 by N1, I2 is V2 by Z2, that equal to V2 by 5, N3 by N1, V3 by 6 ohms. We know that, and also we know that V2 by V1 equal to N2 by N1, V3 by V1 equal to N3 by N1. Apply superposition principle. Okay, so while applying transformation ratio, you forget about the tertiary winding. You take this as a single phase transformer having primary and secondary winding. When you are applying to the tertiary winding, you apply superposition theorem just like that, and you forget about the secondary winding. You think about the tertiary winding is a secondary winding of the transformer, then apply transformation ratio. Okay, just like a superposition theorem, think like that. Okay, think like that. First you think of primary and secondary winding, forget about the tertiary winding. Similarly, while applying transformation ratio to primary and tertiary, think about the secondary winding is absent. So you can apply that. Okay, so you know very well about the concept. I not required to explain about that. Okay, so what is V2 here? I want to find what is V1. This is 10 volts. V2 is 10 volts. N2 is 2 by 1. So V2 is 20 volts. Okay, so V3 by V1, that equal to 3 by 1, so V3 equal to 30 volts. So what is V2 here? 20 by 5, that equal to 4 amperes. What is I3 here? I3 how much? 30 by 5, that equal to 6 amperes. 30 by 5, 6 amperes. So I get V2 is how much? So V2 by 5 is 4 amperes, and V3 by 6 is, V3 30, this is 6, okay, 5 amperes. Okay, V3 by 6 is 5 amperes. Okay, so what is N2 here? N2 is 2 by 1 into 4 plus N3 is how much? 3 by 1 into 5. So 8 plus 5 3 is 15, that equal to 23 amperes. What is how much? What is current I1? 23 amperes. So what is the impedance Z1? Impedance seen by the voltage source, Z equal to V1 by I1. Okay, so V1 how much? 10 volts. What is I1? 23. So 10 by 23 is the answer. Hi friends, welcome to Tneb Gate is Education. Let's consider a three-phase transformer star-star connection having a tertiary winding with unbalanced load. Okay, So I am considering star star transformer with tertiary winding, okay, having unbalanced load with turns ratio n1 is to n2 is to n3 equal to 3 is to 2 is to 1. Let the load current is 100 amperes. What is the primary current? So he asked what is the primary current. Let's see the question how to solve. Okay, so we know very well about the operation of the transformer and well known about the basic concept. Let's just brush up the basic concept. Let I have a coil here. Whenever I am giving the time varying voltage, what happens? From Faraday's law, we know that whenever flux linking with the conductor changes, EMF induced, or rate of change of flux linkages, you have a EMF. This we know, E equal to N into d phi by dt. So from this is from Faraday's law. Okay, we know that whenever the time varying voltage is there, you have a time varying current. Whenever the time varying current flowing through a coil having n turns, you have a MMF, N into I of t. Okay, so you have a MMF, magnetomotive force. Whenever MMF is there, you have a flux. What happens? Flux is there. Whenever the flux is linking with the conductor, that is alternating flux. Whenever the flux linking with the conductor changes, you have an EMF. Okay, so finally you have an EMF. You see here, coil is stationary, flux linking with the conductor changes. That means flux is alternating, coil is stationary. So the EMF induced in this coil is a statically induced EMF. What is the EMF? This is a statically induced EMF. So we know that whenever coil is rotating, flux is stationary. That is called a dynamically induced EMF, that we see in DC machines, DC generator. So what is the EMF induced in this coil? Is statically induced EMF. Okay, so I have a time varying voltage here, I have a time varying current, and time varying current flowing through a coil having n turns, N into I of the MMF, and I have a flux. Let I assume the flux direction is like this. Let the flux direction is like this. Okay, so whenever the flux is there, you have a rate of change of flux linkages will be there. Coil is stationary, flux linking with the conductor changes, you have EMF induced. What you have? EMF induced. So EMF has a unit of the same voltage. Okay, so EMF is also known as voltage. Okay, electromotive force. And you have whenever the voltage is there and you have a closed loop, definitely you have a current. Whenever the voltage source is there, if you have a closed loop, then there will be current. So due to this EMF, you have a current, because this is a closed loop. EMF induced in this coil and having a closed loop, you have a current in this coil, right or not? You have a current in this coil, right? And this current is flowing through the coil having the n turns, right? So you have a MMF. Okay, so you have an EMF according to Faraday's law. Whenever you have a closed loop, you have a current. Whenever current flowing through the coil, you have an MMF, and the MMF produces a flux. Okay, this flux must oppose the main field flux. So this is the direction given by the EMF. So that is given by the Lenz law. So what is the Lenz law says? Lenz law states that effect oppose the cause. effect oppose the cause. What is the effect here? What is the effect here? What is the effect here? EMF. What is the effect? EMF. What is the effect? EMF. What is the cause? Rate of change of flux linkages. What is the cause here? Rate of change of flux linkages. So you can see here, this EMF is a electrical quantity, this flux is a magnetic quantity, so it can't oppose directly. This EMF can't oppose this rate of change of flux cannot oppose directly because it is a magnetic quantity. So for that purpose, this EMF produces a current. That current flowing through the coil having N turns produces MMF. That MMF produces a flux. This flux opposes the main field flux. For that purpose, we are placing the negative sign. So this negative sign represents the direction of the induced EMF. How can you find the direction of the induced EMF? That EMF which in turn produces a current. That current which produces a flux. That flux opposes the main field flux. That flux opposes this main field flux. So according to Lenz's law, what is the EMF there? Statically induced EMF is given by minus N into d phi by dt. This negative sign gives the direction of the induced EMF. This is defined by Lenz's law. This is defined by Lenz's law. Okay. Similarly, if I want to satisfy KVL, you see here what we know from circuit theory, when I have inductance, whenever I have a time varying voltage, what is the, you have a current. Whenever the time varying voltage is there, you have a time varying current. This is a inductance. From from network theory, what is the relation between the, according to Ohm's law, V of t equal to L into di of t by dt. di of t by dt. So this will satisfy. You also you have another formula, N into d phi by dt. d phi by dt. So this formula will be satisfied when V equal to minus E. When I replace E equal to minus N into d phi by dt, N into d phi by dt, that equal to V equal to N into d phi by dt, that equal to L into di by dt. So if KVL to be satisfies, V equal to minus E, that is supply voltage has 180 degrees phase shift from induced EMF. The supply voltage and induced EMF has a 180 degrees phase shift. But magnitude you can see here, magnitude of voltage equal to magnitude of induced EMF. Magnitude of voltage equal to magnitude of the induced EMF. I am not considering resistance and reactance or leakage flux. So under ideal condition, magnitude of the voltage equal to magnitude of the EMF. Clearly see that under ideal condition. If you go for practical condition, you have a resistance drop and leakage flux. I am not considering that. Okay, ideal condition. So indirectly it is also a Lenz's law. Indirectly it is also Lenz's law. What is the purpose of placing a negative sign here? This negative sign is given by the Lenz's law. That is the direction of the induced EMF. Similarly, it is also given by Lenz's law. What is the effect here? Induced EMF. What is the effect here? Induced EMF. What is the cause for induced EMF? Rate of change of. What is the cause for the rate of change of flux? MMF. What is the cause for the rate of MMF current? What is the cause for current voltage? So this is electrical quantity, this is electrical quantity. Okay, there will be a opposition. So between two similar quantities, you have 180 degrees phase displacement. Between electrical quantity and magnetic quantity, you have 90 degrees phase displacement. Between electrical quantity and magnetic quantity, you have a 90 degrees phase displacement. Between the magnetic quantity and so between electrical quantity and electrical quantity, you have 180 degrees phase displacement. Between electrical quantity and magnetic quantity, you have a 90 degrees phase displacement. Let's see. Let flux is sinusoidal. Let flux is sinusoidal. Flux equal to phi m sin omega t. So time varying flux is na. So flux equal to phi m sin omega t. What is induced EMF? Minus N into d phi by dt. So minus N into d by dt of phi m sin omega t. So N into phi m cos omega t into omega. So I can write this as N phi m omega sin of omega t minus pi by 2. So you can see here, if flux is reference, induced EMF lags flux by 90 degrees. But you can see here supply voltage is opposition of V equal to minus E. So you can see here, between electrical quantity you have 180 degrees phase shift. Between electrical quantity and magnetic quantity you have 90 degrees phase shift. Okay, so this is the basic. And you can see here, if I have a transformer, if I have a transformer, what happens in transformer? Let's see. If I have a transformer core, okay, let I have this, and I have a winding here. When I have a time varying voltage, here, you have a time varying current, and it passes through the N1 turns. You have a flux MMF, and this flux direction is like this. The same flux linking the primary and secondary winding, you have induced EMF E1 and E2. So this E1 is called statically self-induced EMF. E2 is called statically mutual induced EMF. Why mutual induced EMF? The flux linking the secondary coil due to the current in the first coil. Due to the current in the first coil. Flux linking the second coil due to the current in the first coil. Okay. So if I place a load, if I connect the load here, you observe here, if I connect the load here, closed loop will be formed. I have a voltage, induced EMF is a voltage, it is a current will flow. So due to this EMF, having the current from basic, you see here, due to this EMF, I am getting the current due to the closed loop. Okay, so this current produces a flux flowing to the N2. That flux opposes this main field flux. Okay, that flux opposes this main field flux. Okay, so from this you can see here, net flux is phi minus phi 2. Net flux is reduced. Means EMF is reduced. When EMF is reduced means KVL is not satisfied. Okay, so I equal to V minus E by, let's think Z. So induced EMF is reduced, current draws more current, such that primary winding current draws more current I1 of T, such that it produces phi 1 of T. It cancels the phi 2. So it produces a flux, it draws extra amount of the current, such that it balances the secondary flux, neutralize the secondary flux. Finally, the main flux in the transformer core remains the constant. So let us consider ideal transformer. If I consider the ideal transformer here, I am considering ideal transformer. Let I am supplying the voltage, time varying voltage here. Okay, and I have a current. But what is the ideal transformer condition? Permeability of the transformer core is infinity. So permeability of the transformer core is infinity means what happens to reluctance? Reluctance equal to L by mu naught mu r into A. Okay, I can take single permeability. So permeability is tends to infinity means reluctance equal to 0. What happens to flux here? Flux equal to MMF by reluctance. So reluctance tends to 0 means flux tends to infinity. So this is not the correct. If you see here, limit x tends to 0, sin x by x equal to 0 by 0. That equal to 0, indefinite form. So what we do there here, limit x tends to 0. What happens? We are applying L'Hospital rule, call sin x is cos 1. So finite value. So limit x tends to, so denominator tends to 0. The function sin x has a finite value. Limit x tends to 0. The function sin x by x has a some finite value. Okay. Similarly, you can see here flux equal to MMF by reluctance. So MMF is Ni by reluctance. So once our transformer is designed, this turns is constant. Okay, so this reluctance equal to 0, this current tends to 0 only, then you have a finite flux. So if I have a 0 by 0 form, if you apply L'Hospital rule, then you get the finite amount of the flux in mathematical concept. Okay, so in term of that, so even though current equal to 0, you have a finite amount of the flux there. You can go for graphical methods also if you consider BH curve. if you consider BH curve of the silicon material, then you go for that. So meanwhile I want to solve the problem. So meanwhile understand this. So 0 by 0 form, you get the finite amount of the flux. Okay, so even though I am giving the supply voltage, there is no current under the ideal condition. Okay, so you have a flux in the transformer. This is N1 turns and this is N2 turns. Okay, so you have induced EMF E1 and induced EMF E2. Okay, if I connect the load here, I place here. Okay, due to this EMF I have a current. This current produces flowing through the N2 produces a MMF. This flux produces a phi 2, and this flux, suppose the main field flux, net flux is reduced. For that it draws additional component of the current I1. So that is, it produces a flux phi 1, it cancels phi 1 and phi 2. So from this, N1 MMF N1 I1 equal to MMF N2 I2. So whatever the flux produced by the secondary, flux, secondary MMF produced, it should be compensated by the primary MMF. This is called a MMF balance. So clearly observe that the flux opposes the secondary flux opposes the main field flux. Or you can see here the MMF N1 I1 producing flux opposing the secondary flux N2 I2. MMF produced by the primary flux N1 I1 is opposed by N2 I2. Okay, so we know from basic, suppose if I have two coils there, and I have a dot there, if current enters the dot in both the coils, or current leaves the dot in both the coils, then two fluxes aids each other. That means two fluxes are in series aiding. Okay, two fluxes are in series aiding. Okay, two fluxes are in two fluxes aids, net flux increases. So the flux in this direction only and this flux in this direction only. So net flux is phi equal to phi 1 plus phi 2. So net flux is increased whenever the current enters the dot in both the coils, or current leaves the dot in both the coils. Net flux is increased. The net flux aids each other. Okay, otherwise if you see here, if current enters the dot in one coil, current leaves the dot in another coil. Suppose if current enters the dot in one coil and current leaves the dot in another coil, okay, then the flux oppose each other. So suppose this flux in this direction, this flux in this direction. So net flux oppose each other. Net flux is phi 1 minus phi 2. So net flux reduces. So you can see here, this if you consider main flux or secondary flux, or if you consider primary MMF, secondary MMF, both are opposing. So from this it is a negatively coupled circuit. So if current enters the dot here, current leaves the dot here. So then only MMF balance will be there. So N1 I1 equal to N2 I2 only when if current enters the dot in primary, current leaves the dot in secondary. Then only you have clearly the MMF balance. N1 I1 equal to N2 I2. I am considering the ideal condition. Okay, so N1 I1 equal to N2 I2. What is the meaning in that? Okay, means the current enters the dot in one terminal, means current leaves the dot in another terminal. That flux oppose each other. So you can see here, N1 I1 equal to N2 I2 means N1 I1 minus N2 I2 equal to 0. Net MMF, that is phi 1 minus phi 2 equal to 0. So net flux cancels each other. Okay, so this is the MMF balance. So let's come to the question here. You see here, this is the question. Two three-phase star connection with tertiary winding having a load current of 100 amperes. He asked the primary current. Let's see this. If I have a, you see, if you have observed in the single phase transformer, if ideal condition, current, initial current equal to 0. If I place a load, I have a secondary current, I have reflect current of I1. I1 according to transformer action. So I have a secondary current here in phase A. This is phase A and this is phase B and this is phase C. In the secondary load, in the secondary side, I have a phase current, phase A current. See, I have a reflect current of, according to, you see here transformer action, you see the transformer action. If I have a secondary current, to compensate that, it draws a same current. To compensate the flux, it draws some amount of the current such that it cancels each other. So I have a current in this. How will be the direction? You see here current leaving the dot such that it current enters the dot. So one leaving the dot means another transformer should have enter the dot, then only you have a MMF balance. Okay, so I have a current IA here. So from this it comes here center, it divides IA by 2. But you see here MMF, here phase A MMF is balanced, but phase B, phase C MMF is not balanced, because in secondary winding there is no current. Because of unbalanced load. Okay, so for that purpose here MMF balance is not coming there. So MMF balance condition is not coming to picture. So here MMF balance, phase A have a MMF balance, but phase B, phase C have not MMF balance. Okay, so here for this balance condition I am placing a tertiary winding. This is I2 current, this is I1 primary current. Okay, I have a secondary current in phase A, I have a reflecting primary current in phase B. Okay, and I dividing this primary current I1 by 2. So I have a, for this compensating this, I have a I3 current. In tertiary winding I have a current like this, because here for balancing this I have MMF. I want to require MMF balance. Here current leaving the dot, it should current enter the dot. Here so dot I have to replace here, current enter the dot here. Okay, so what is the purpose of the tertiary winding? Here to balance this currents, how the second the phase B, phase C MMF has, phase B and phase C has a current here due to this secondary current, due to the unbalanced load current. I getting the current in the phase B and phase C. Here phase B and phase C MMF balance is not going on, is not getting. Okay, for that I am placing the tertiary winding to get the MMF balance. So let's see the MMF balance of the phase A. MMF balance of phase A. MMF of balance A, MMF of phase A, MMF balance of phase A. You can see here current entering, here also. So here current entering the dot, here current entering the dot. You can see here current leaving the dot. So MMF of phase A is N1 I1. So this have N1 turns, this has N1 turns, this has N2 turns, secondary winding, this is tertiary winding, N3. So N1 I1 here entering the dot. Here you can see here I am considering only phase A, N2 I2 equal to current leaving the dot. So N3 I3, okay, N3 I3, N1 I1 equal to N2 I2. This is secondary winding. Okay, and MMF balance of phase B. MMF balance of phase B, that equal to, here phase B you have current leaving and you have phase B current entering. So N1 I1 by 2 equal to current entering, current leaving, here current entering, N3 I3. But you know here N2, so N2 current is 0. Similarly phase C is N1 I1 by 2 equal to N3 I3. I3. So you can see here I3 current is flowing like this, N3 I3. So you see here the N3 current, I3 current is flowing like this. So current entering the dot, current entering the dot. So observe the MMF balance equation. Observe the MMF balance equation. So you have to understand the MMF balance equation. When current entering the dot and current leaves the dot, then only you get the MMF balance. Then you get the MMF. So MMF balance equation you get. So clearly current entering MMF current entering equal to current leaving. That is the MMF balance equation I written here. Okay. So I know here N1 I1 2 I1 by 2 equal to N3 I3. N1 I1 by 2 equal to N3 I3. I write here. This is equation 1 and this is equation 2 and this is equation 3. I write N3 I3 equal to N1 I1 by 2. So N1 I1 by 2 equal to N2 I2. I1 2 3 I1 by 2 into N1 equal to N2 I2. So I know I2 equal to 100 amperes. I1 equal to 2 by 3. What is N2 here? 2. N1 here 3. What is I2? 100 amperes. That equal to 4 by 9 into 100 amperes. That equal to 400 by 9 amperes. So this is the solving the problem if you have a tertiary winding. Okay, so you can get the question in TRB Polytechnic lecture and AP Transco also. So this is simple question. If you know the basic concept, that is if you know the basic concept, then it is easy to solve the problem. Okay, so if you go for Transco or TRB Polytechnic lecture or any SPDCL, that the difficulty of the exam for every year it is going to be tough. So you have to prepare advance. You have to prepare in advance and you have to revise all the things. Okay, thank you friends. Study well. Thank you. Hi friends, welcome to KMED GATE's Education. Let's see the first question. The question given is a series RLC circuit has a resistance of 10 ohms and a resistance of a series RLC circuit having a resistance of 4 ohms and I have an inductance L and I have a capacitance C 2 farads. Okay, he asked the value of the inductance L if it is a critically damped. Here if I have a supply voltage V of t, I have a response I of t. We know from the control system the transfer function is nothing but Laplace transform of response to the Laplace transform of input. Here what is the input? V of t. What is the response? I of t. So I want to find I of s by V of s. If I found this, I get the transfer function. Okay, and he said that the circuit is a critically damped. So it is a second order circuit. The series RLC circuit is a second order circuit. We know from the control system the standard second order transfer function is C of s by R of s equal to omega n square plus s square plus 2 zeta omega ns plus omega n square. The complete second order system is analyzed by this damping factor. If at all zeta equal to 0, it is undamped system. You have the response having the constant amplitude frequency of oscillation. Okay, if zeta equal to 0, poles lies on imaginary axis which are not repeated. Okay, and you have 0 less than zeta less than 1, it is underdamped system. It is underdamped system. Okay, you have the response like this. You have the response like this. Okay, damped oscillations. The pole locations are lies on left of S plane, that took complex conjugate. Zeta equal to 1, it is a critically damped. Okay, you have a one damped oscillation. You have one damped oscillation. For this, you have the poles lies on real axis and have an equal magnitude. A zeta greater than 1, it is a over damped system. You have two poles, one pole towards imaginary axis, one pole away from the imaginary axis. It is also a one damped oscillation. Okay, one damped oscillation. This is called a dominant pole or significant pole. This is insignificant pole. Okay, so this is significant pole, this is insignificant pole. Let's convert this series RL circuit to the standard second order system. Apply KVL here. Minus V of S plus I of S into R plus SL plus 1 by SC. I of S by equal to SCR plus S square LC plus 1 by SC, that equal to V of S. V of I of S by V of S equal to SC. If I take LC common, I have S square plus SRC by LC by 1 by LC. Okay, CC cancel. Okay, CC cancel. Let's compare this denominator, standard second order denominator, to this denominator. Check it, compare this. Okay, so compare this. So 2 zeta omega n equal to R by L. Here CC cancel and omega n square equal to LC, 1 by LC. Okay, so from this you can see here omega n equal to 1 by root of 2L. Omega n equal to 1 by 2L. For critically damped system, zeta equal to 1. So 2 into omega n is 1 by root 2L, that equal to R by L. What is the value of the R? This is 4. These two 2's. Okay. So if I square it, 1 by 2L, that equal to 4 by L square. So here LL cancel, L equal to 8 Henry. So answer is 8 Henry. Okay, so here one thing you have to observe. You see here the denominator. You see here the denominator is S square. Denominator is S square plus R by L into S plus 1 by LC. 1 by LC. For series RLC circuit, at resonance, what is bandwidth? Bandwidth equal to R by L. What is the resonant frequency? 1 by root LC. 1 by root LC. You know very well about that. At series, for series RLC circuit, at resonance, bandwidth equal to R by L, omega naught equal to 1 by root LC. Okay, so you see here, this is a bandwidth. This is a bandwidth, and this is of resonant frequency omega naught square. Okay, so in this, if we ask the question, this R by L is a, in this denominator, in this transfer function, if at all resonance, series RL circuit is at resonance, this is a bandwidth or resonant frequency, he will ask. Okay, so this directly, so if he given directly the denominator of the transfer function, so what is the bandwidth? Okay, so he directly given the second order system, so omega n square plus s square plus 2 zeta omega ns plus omega n square in this form. Okay, for series RLC circuit, what is the bandwidth? Bandwidth is a 2 zeta omega n. What is a resonant frequency? Resonant frequency is a omega n square. Omega n square is a resonant frequency. So kindly observe this. Kindly observe this. Okay, so you know very well at series resonance bandwidth. The bandwidth is also known as bandwidth. You can write as omega naught by quality factor. So how it came means bandwidth equal to omega naught by quality factor. Omega naught equal to 1 by root LC, quality factor equal to 1 by root of L by C for series RLC circuit. So I can write this as 1 by root LC into R into root C by root L. So root C here, root C cancel, root L into root L is L. So bandwidth is R by L. Bandwidth is R by L. So kindly remember this. If you have a given the in question, if you given the question having the resistance and L value and R value is given, what is the bandwidth? It is a R by L. Let's see the next question. So here a 12 volt automobile battery is connected to a 12 volt. Here it is given as a 12 volt automobile battery is connected to a 5 ampere headlight. 5 ampere headlight. Energy consumed in 1 hour operation. Energy consumed in 1 hour operation. So we know that power equal to time rate of flow of electrical energy. Time rate of flow of electrical energy. So energy equal to power into time. So I want to find the power. So power equal 12 volts and the 5 ampere is going to this lamp. 5 ampere is going through this lamp. So 12 into 5 into time is 1 hour. Energy consumed in 1 hour. So 12 5 is 60. 60. Okay, into 1. So answer is you get to get 60 joules. 60 joules. Answer is none. First you put the tick mark here. For I put the tick mark and come out of the exam after seeing that key, then it will be wrong. So here, what is the power unit? What is the unit of the power? What is the unit of the power? Joules. What is the unit of the power? Joules per second. Joules per second or watts. Joules per second or watts. Okay, joules per second or watts. Okay, so this time is in seconds. This time is in second. So the energy consumed in 1 hour. So 12 into 5 into 1 hour means 60 minutes. So I can write 12 into 5 into 60 into 1 minute equal to 60 seconds. 60. So 12 5s are 60. 6 6 are 36. So 6 6 36. 6 3 say 18. 18 to 21. So 216 something kilojoules should be there. So answer is 216 kilojoules. So units will be very important in calculating the problems. Okay, if you consider this as hours, then we directly go to the option none. But the unit is in seconds, joules per second. Unit of the power is joules per second. Okay, so next, let's see the next question. So let's see the next question here. In the circuit shown below, 5 ampere source supplies no power. Here one hint is given. The hint given here is the 5 ampere source. The hint here is the 5 ampere source. The 5 ampere source supplies no power. Power equal to V into I. So let I have a voltage here, plus or minus V here. So power supplied by the 5 amperes is 0. That is voltage into 5 equal to 0. That means here the node voltage is 0. So indirectly he is given that node voltage equal to 0. Simply I read on the circuit such that plus or minus 30 volts. Here I have 3 ohms. Here I have 2 ohms. Simply this is a short circuit. I have a 5 amperes and I have 8 ohms here, and this is plus or minus Vs. I have a 6 ohm here. Apply nodal analysis here. If I apply nodal analysis, 0 minus 30 by 5 plus minus current entering 5 amperes, 0 minus Vs by 14 equal to 0. So minus 30 by 5 minus 5 Vs by 14. 5 5 is 25, 25 plus 30, 55. So minus 55 by 5 equal to Vs by 14. Whether I am right? 5 5 is 25, 25 plus 30, 55, 55. So I get 5 11s. So 14 into 11, that equal to 14, 154. So I will get minus 154. Answer is minus 154 is the answer. Let's see the next question. Consider the network which consists of the resistors and voltage source. If the values of the all voltage source are doubled, then the value of the mesh currents, what happened? Okay, apply superposition theorem. Apply superposition here. If you apply the superposition theorem, if the voltage here, two conditions is satisfied. One is linearity and homogeneity. So we know very well that for superposition theorem, two conditions must be holds, that is a linearity condition and homogeneity. So what is homogeneity? Means if excitation is multiplied by a constant k, then the response is also multiplied by a constant k. For example, let's see this. Let I have 2 volts here, 1 ohm here, I have 1 ohm here, I have 1 ohm here. Let's take. Okay, so what is the current now? 11.5. 11.5. Let's take this is a 0.5 ohms. Let's take this as a 0.5 ohm. Okay, so 1 is parallel 0.5 plus 0.5 1. So you get 2 by 1, that equal to 1 ampere. 1 0.5 plus 0.5 is 1. Okay, resistance is 1. I equal to V by R. V equal to IR. I equal to V by R. 2 by 1 is sorry, 2 by 1 is 0.5, 2 amperes. 2 by 1 is 2 amperes. Okay, so here when it comes to here, if you see here, when it comes to here, both resistance are equal. I get 1 ampere, I get 1 ampere. Okay, let I take 6 volts here. Let I take 6 volts here. 6 by 1 0.5 plus 0.5 1, I equal to V by R. 6 by 1 is 6 amperes. So I will get 6 amperes. Here I will get 3 amperes. If I take green color shows I am taking the voltage source is 6 volts. So here it divides into 3 amperes. 3 amperes. What happens if I multiply the excitation by 3 volts 3 times? If I increase the excitation by 3 times, the response is also 2 into 3, 6 amperes. Okay, 1 into 3, 3 amperes. 1 into 3, 3 amperes. Okay, so if excitation is multiplied by 3, the response is a response in all the branches also multiplied by 3. This is called a homogeneity. So you see here, resistance and voltage source only if all the values of the voltage source are doubled. So if I voltage source are doubled, then the values of the mesh currents also doubled. The values of the mesh currents also doubled as per superposition theorem. As per superposition theorem. Okay, superposition theorem. Hope you understand. Let's see the next question. Let's see this question. He asked the Thevenin's equivalent of the circuit. You try this. You try this and give the answer in the comment box. You try this. Give the answer in the comment box. Okay. So I find let try. Okay. Let try and give the answer in the comment box. If you like the video, share to your friends. Okay. Thank you. Hi friends, welcome to K-Made Gate's Education. So let's see the first question. To minimize voltmeter loading, the voltmeter operating current has to be small, the voltmeter operating current has to be high, resistance connected in series with the coil should be low, resistance connected in parallel with the coil should be high. So one thing we know, what we know, the voltmeter has a series resistance. Voltmeter has a series resistance. Ammeter has a shunt resistance. Ammeter has a shunt resistance. So resistance connected in parallel, we can neglect this option. And in ammeter shunt, the RSH should be low. In series resistance, it should be high. Okay, so resistance connected in series with the coil should be low, this neglected option. And finally you have these two can be option. Any of these two can be an option. Let's see what we know. The voltmeter, suppose if you consider circuit theory, ideal voltage source, this is an ideal voltage source. Practical voltage source, this is practical voltage source. In practical voltage source, you have a resistance in series with the voltage. Okay, if you consider ideal current source, this is an ideal current source. If you consider practical current source, you have a resistance in parallel with current source. While coming across in measurement, if you consider this is a voltmeter, this is an ideal voltmeter. If you consider practical voltmeter, you have a parallel resistance. If you consider this is an ammeter, ideal ammeter, if you consider practical ammeter, you have a series resistance. Series resistance. Okay, so if you play, suppose if I have a resistance, suppose if I have some network, okay, if I have some network, if I have a some network, if I place a voltmeter across it, okay, so this is having a resistance of parallel resistance. To minimize this will be the loading. What will be the loading? This extra resistance will be the loading. This has to be taken into account. Okay, so if this current is small, if the current going to this is small, okay, if I take this current going to this is small, then what happens? Resistance will be high. What happens? This resistance is high. So resistance is high means this can be simply acts as a open circuit. This resistance can be neglected. Okay, so this will be equivalent to ideal voltmeter. This will cause the loading effect. This internal resistance of voltmeter causes loading effect. So if it draws a low current, that means it has a high resistance. Okay, so the question may be asked, the current to be small or resistance to be infinity, or high. Okay, so loading means this series, suppose if you consider this voltmeter, ammeter having a resistance RS meter resistance, and I am connecting series resistance. This is a voltmeter. This series resistance, this meter resistance does not affect the load, does not affect the loading. Okay, does not coming to this will not affect the loading. The resistance which have internal across this will affect the loading. Similarly, ammeter series resistance will affect the loading. You have to keep in that mind in that. Okay, you have to keep mind in that voltmeter having a parallel resistance, ammeter having a series resistance. Ulta, from circuit theory to measurements, it is a ulta. Okay, they are considering voltage source, here considering voltmeter. There is a series resistance, there is a parallel resistance. Okay, hope you understand. So this internal resistances affects the loading, creates the loading. Okay, next question. Let's see the next question. He have given that what is the multiplying power of the shunt resistance when use the galvanometer of 1000 ohm resistance. This is an ammeter, galvanometer. You have a meter resistance 1000 ohms and you have a shunt resistance of 200 ohms. We know that RSH equal to Rm by m minus 1. What is RSH? 200. What is meter resistance? 1000. This is multiplying factor m minus 1. M minus 1 equal to, so 5, m equal to 6. M is equal to 6 is the multiplying factor. Let's see the next question. Right, let's see the next question. The power consumed by the balancer 3-phase load is measured by a 2 watt meter method. The meter readings are you have 8 kilowatts and 4 kilowatts. The power factor of the load, we know that phi equal to tan inverse of root 3 into P1 minus P2 divided by P1 plus P2. So what is tan phi? Tan phi equal to root 3. What is P1? 8 minus 4, 4 by 12. 4 3s, that equal to 1 by root 3. Sin 30, 1 by 2. So phi equal to 30 degrees. Okay. So what is power factor? Cos 30 degrees. Cos 30 is root 3 by 2. That equal to 0.866. That is, answer is between 0.5 and unity. Answer is D. Let's see the next question. So let's see the next question. The least number of single phase wattmeters required to measure total power of an unbalanced load. So let's note these points. For unbalanced load of 3-phase 4-wire system, you required n minus 1 wattmeter. So n is n phase, sorry, 4 wires. So 4 minus 1, 3 wattmeters. Okay, so 3-phase 4-wire system Let note this 3-phase 4-wire system unbalanced. You have 3 wattmeters required. So for balanced 3-phase 4-wire system, for balanced you have only single wattmeter is required. For 3-phase 3-wire, balanced or unbalanced, unbalanced, you have only required minimum 2 wattmeters. So carefully note these points. 3-phase 4-wire system unbalanced, you have required 4 minus 1 3 wattmeters. For balanced you have required only single wattmeter. For 3-phase 3-wire balanced or unbalanced, minimum 2 wattmeter is required. So here the question is given that unbalanced load, so 4-wire system therefore require 3 wattmeters. Okay, let's see the next question. So what is the next question given? In phantom loading arrangement, energy consumption in the calibration test of the wattmeter is reduced because what do I do in the phantom loading means you separate the current coil and giving this low voltage DC supply to this current coil. Okay, so that is the reason energy consumption is reduced. Because we are separating the current coil. You have a current coil and pressure coil in the wattmeter. Current coil in series with the load, pressure coil is connected across the supply actual wattmeter. So what we do in the phantom loading means we are separating the current coil and we are giving separate low voltage DC voltage, low voltage supply across the current coil. Okay, so option D is the answer. Okay, next question. So what is the question given here? The instrument whose deflection is given by equation theta is proportional to I square into dm by d theta, right? So we know that for PMMC deflecting torque is equal to NBI into A. So this is number of turns, this is flux density and current, and this is area. Okay, so this is a deflecting torque. This is principle is depend upon Lorentz force or motor principle. Current carrying conductor placed in a magnetic field subject to a force. Next you see here moving iron. Deflecting torque is equal to half I square dl by d theta. So operation based on the change in self-inductance. Operation is based on the change in self-inductance of the coil. Next you consider electrodynamometer. Operating principle based on change in mutual inductance. So deflecting torque is proportional to I1 I2 dm by d theta. So if I consider ammeter, current flowing through the series coil and current coil is same, that is current coil and potential coil is same, you get I square dm by d theta. Okay, so this is of relation for electrodynamometer. So you can see here this is a mutual inductance, is there, that's why it is a electrodynamometer type instrument. Next question. Let's see the next question here. A 0 to 200 voltmeter has an accuracy of 1% of the full scale reading. So 200 voltmeter has 1 by 100, that equal to 2. So this is the accuracy of 1% of the voltage measured is 50 plus or minus 2. This is error. What is limiting error? 2 by 50 into 100. So 52, that equal to 4%. So limiting error is 4%. So hope you understand. So let's see here. You have an accuracy of 1% of the full scale reading. If you see here, 1 by 100 into 200, that equal to 2. That means you have 200, so 2 plus or minus 2. You can, if you measure the voltage, suppose if you measure the 200 volts of voltmeter, if you measure is 150, if you measuring 150 volts, so the accuracy means 150 plus or minus 2, so I can get 152, or I will get 148 volts. So I will get in this range. So the limiting error is 2 by, so the measure value is 50 volts, so 50 plus or minus 2 volts. Okay, so limiting error is 2 by 50 into 100. This we have to calculate. Alright, let's see the next question. See the next question. A guard terminal is a measurement of high resistance. You see here, we know that the high resistance consists of 3 terminals. Okay, so this is terminal 1, this is terminal 2, and you have this is terminal 3. You have 3 terminals. So this is a guard terminal. It is to bypass the leakage current. It is used to bypass the leakage current. Okay, so high resistance has a 3 terminals and low resistance has a 4 terminals. Low resistance has a 4 terminals. So you have to clearly observe the medium resistance, high resistance, and low resistance, and what are the measurement types. So what are the measurement types, you have to check that. Okay, so write notes on that. Clearly you can get an idea. Okay, let's see the next question. So you can see here the next question is Lysage's pattern is given, the frequency ratio of the vertical signal to the horizontal signal. So he asked that if vertical signal Fy and horizontal signal X is equal to number of horizontal cuts by number of horizontal cuts by number of vertical cuts. Number of vertical cuts. You can see here horizontal cuts. How many will come into picture? Let's see here clearly. Okay, horizontal cuts. This is 1, and this is 2, and this is 3, and this is 4, and this is 5, and this is 6. Vertical cuts you observe here. I will take here. So let take here. So this is 1, and this is 2, and this is 3, this is 4. 2 is to 2 is the answer. 3 is to 2 is the answer. Let's see the next. So let's see the next question. He given that in series RLC circuit excited by the voltage source E equal to E sin omega t, where LC equal to 1 by omega square. You can see here LC less than 1 by omega square. That means omega square less than 1 by LC. So omega less than 1 by root LC. That is, it is a resonant frequency. Omega naught is less than root of L by. So it less than 1 by root omega is 1 by root LC is a resonant frequency. Okay, it is not. So omega less than 1 by root LC. Omega 1 by root LC is a resonant frequency. Okay, so below resonant frequency in series RLC circuit, leading in nature. Leading in nature. So leading in nature means current leads the applied voltage. So phase, it correct. It is above resonant frequency. It is above resonant frequency. So current in phase at resonant frequency. It is also at resonant frequency. At resonant frequency, voltage and cross inductance and capacitance are equal at resonant frequency. So answer is this. Let's see next question. Let's see the next question here. The value of the load impedance ZL for which load consumes maximum power. Okay, so we know that for ZL equal to ZS conjugate. Okay, I will go for this 30 minus J40, but I don't have answer. 30 minus J40 is not there. 30 minus J40 is not there. 30 minus J40 is not there. Something it is given 50, 50, 30. So what do we do here? We prove for none of the above. If you put in the exam hall and come outside of the exam hall, then you get the answer is wrong. So let's see here. What is magnitude of ZL? So magnitude of ZL equal to root of 30 square plus 40 square. What is this? 900 plus 1600 root of 2500, so 50 ohms. So I get 50 ohms. So this is wrong, this is wrong. 50 ohms is correct, 50 ohms is. I want to perfect. Cos phi equal to R by Z. So what is R here? 30. Z is how much? 50. So 0.6. I will get 0.6 right. So lag or lead? It is the question here. What is the question here? Lead or lag? Okay. So what I get here ZL is here is ZL equal to 30 minus J40. So this is something look like R minus JXC. If I have RL equal to ZL equal to RL plus JXC, R minus JXC, compare with these equations, what I get? R minus JXC. So it is a leading in nature. So I neglect this option, I go for this option. Okay. So hope you understand. So let's see some more questions in next video. If you like this video, please share to your friends. Okay. Thank you.